we are going to be applying Newton's method to a nonlinear equation. So the first thing that I like to do is just graph the equation that I'm going to be working with into either my graphing calculator or something such as GeoGebra. And so looking at the graph, I can see that there's going to be one root in between -1 and -2, and then there's another root slightly greater than 1. So for our purposes here, let's solve for the root that's in between -1 and -2. So I have Newton's method written down right here. And so to use Newton's method, I need to choose an x sub naught value. So for my x sub naught value this time, because I'm solving for the root in between -1 and -2, I'm just going to choose -1. That'll just make it somewhat easy for us. And as you can see here, we have your f of x function and also the derivative of that function. So if I take the derivative, of x to the 4th plus x minus 3, it's 4x cubed plus 1. Alright, and now I can substitute my x sub naught values into those two equations, which is our -1. So it's -1 to the 4th. Alright, that's going to give you a -3. If I do the same thing for the derivative, that is going to also be -4, -3. And then I can substitute this into the Newton's method equation. This will give us our x sub 1 value. And that will give us -2. So our x sub 1 value is -2. Now we will substitute this x sub 1 into our original equations again, just like we did with our x sub naught. And I don't like to make mistakes here, so I will just plug that into my calculator. Which will give us 11. Doing the same thing for the derivative. Again, just going to put this into the calculator. So -31. And then when I substitute everything into my Newton's method equation, it's going to give us our x sub 2 value. We know a negative divided by a negative is positive, so we can really just add that fraction. And that gives us an x sub 2 value of -1.645. So I'm going to put that into my table. So far it doesn't look like our series is converging, so we're going to do it again. Solve for x sub 3. So we're going to plug our x sub 2 value into our f of x equation and our f prime of x. Again, just putting that into the calculator. That is about 2.6776 approximately. Now substituting that in for our derivative. Again, putting that into the calculator. It's a negative 16.806 approximately. Then we can use Newton's method formula to get our x sub 3 value. Again, a negative divided by a negative in a fraction is going to be positive, so we can really just add that fraction. And we get an x sub 3 value of negative 1.4857 approximately. Again, it doesn't appear that we're converging, so we are going to complete the algorithm again to get our x sub 4 value. So first we plug in our x sub 3 into these two equations up here. Alright, into the calculator that goes. Oh, I made a mistake here. 4857 to the fourth. Alright, that is about 0.3865. You're going to do the same thing for the derivative. That's about negative 12.1176. And then we are going to use Newton's method again to get our x sub 4. Putting that into the calculator. And then a negative divided by a negative is going to be a positive fraction, so I'm just going to add that fraction right there. And this gets about negative 1.4538. For our x sub 4 value. So we're going to keep going because it still does not appear to be converging. So as you can see, this algorithm can get quite lengthy. You know what, let's just put our paper here. Alright, so now we're going to substitute our x sub 4 values into these two original equations here. Again, using our calculator. We get about 0.01323. Now doing the same thing for the derivative. a negative 11.29 approximately, using Newton's method. Negative 1 point, just the equation of Newton's method is what we're using again. Again, a negative divided by a negative in our fraction is going to give us a positive, so I'm just going to add that fraction. And we get about negative 1.4526 for x sub 5. We're going to put that into our table. It looks like our series converges to negative 1.45 about, and looking at the graph, that would make sense as well, but let's just continue on and make sure that our x sub 6 also converges to about negative 1.45. Alright, so we're going to plug in our x sub 5 into our f of x, original f of x equation again. And then when we plug that into the calculator, we're going to get a really small decimal. Alright, and then we're also going to put that, our x sub 5 value in for our derivative. That's a negative 11.26 approximately. So going back and using Newton's method equation, can put that into our calculator. That's going to be a positive fraction, because a negative divided by a negative is a positive. And we get about negative 1.4525. We can put this back into our table as well. And I would definitely say our series is converging to about a negative 1.45. If we continued with this series, we should also see that as well. Now I'm going to have you guys solve for the second root, so the one that's slightly greater than 1, using Newton's method, and I will post the solution below this video.